लाइव करो। ओके ओके स्टार्ट सामने
Good morning to one and all present here. I, on behalf of the University of Engineering and Management, extend a warm and respectful welcome to each one of you to the 13th International Conference on Intelligent Embedded Microelectronics Communication and Optical Networks, IEMECON 2025, being held from 8 to 10 December 2025 in hybrid mode. I, Dr. Anjali Yadav, Associate Professor from EC Department, have the honor of serving you as an anchor for the proceedings of Day 2. I am truly delighted to see this august gathering of eminent researchers, academicians, industry experts, and young scholars joining us both in person and online to deliberate on cutting-edge developments in intelligent embedded systems, microelectronics, communication, and optical networks. Moving on, I now take this opportunity to formally invite our distinguished guests and in-house dignitaries to the dais. It is my privilege to request Dr. Sayok Rao, Associate Professor and Head, Department of Electronics and Communication Engineering from Central University of Rajasthan, to kindly come forward and take their seat on the stage. So, now I request our in-house dignitaries, Professor Dr. Vishwajal Chatterjee, Honorable Vice Chancellor, University of Engineering and Management, Jaipur, and Dr. Pradeep Kumar Sharma, Sir, Registrar, University of Engineering and Management, Jaipur, to kindly come on the dais. I extend a very warm welcome to all of you and thank you for sparing your valuable time to be with us today. We now proceed to a brief felicitation ceremony as a humble expression of our gratitude and respect towards our esteemed guests. May I request the organizing team to please assist with the felicitation. Now I request Professor Dr. Vishwajal Chatterjee sir and Dr. Pradeep Kumar Sharma sir to felicitate Dr. Sayok Rawat, Associate Professor and Head, Department of Electronics and Communication Engineering, with a token of respect. Thank you, sir. Thank you so much, sir. Now, without any further delay, let us start with the keynote session of Day 2 of IEM Econ with our first keynote address by Dr. Sayok Rawat. Dr. Rawat is currently serving in the Department of Electronics and Communication Engineering at Central University of Rajasthan. He has over 21 years of academic and research experience and holds qualifications in Masters in Microwave Engineering and Doctorate in Planar Antennas. He has published more than 120 papers, supervised multiple postgraduate and doctoral scholars, contributed to many conference proceedings, and his research interests include reconfigurable RF circuits and microwave integrated systems, while also being associated with prestigious professional bodies and having represented India in several international academic forums. We are deeply honored to have him with us today. Sir, may I now request you to deliver your keynote address?
Online, offline, check. Online activities are there.
स्टार्ट करते हैं ना
Online activities.
Of recording in progress. Our research is to design a compact, high-performance, circularly polarized ceramic high-level resonator microantenna, which is suitable for 28 GHz 5.
No audible.
यस सर यस
So very good morning to all of you. I'm Dr. Sayyid Rawat and I'll be giving a talk on antennas. I hope all of you are well versed with antennas. How many undergraduate students over here? None? PhD scholars? So all faculty members. I prepared the talk as per so that it could give you some knowledge about antennas, even if you are not from same field. So antennas have become a very integral part of our communication system. So there's one book by Balanis. He's a very well-known person. It's considered to be like a Bible for antennas. So what he has said is that the antenna serves to the communication system the same purpose that eye and eyeglasses serve to a human. So it is that vital, important component in the field of communication. I'm not saying that others are not important, but that is also one of the important parts. I can give you one example. There has been a paradigm change in the way antennas are being used. I shall give you an example of automotives. Okay, many of us, being a salaried employee, we used to own a mid-segment car, isn't it? When I say mid-segment car in today's scenario, it is something which is ranging between 5 to 50, 20 lakhs. That would be considered as a mid-segment car. So what do you think? How many antennas we have in a car, a mid-segment car? I'm not talking about high-end. What do you think? Any guesses? Any answers? One. Okay. One. Where it is? That's a sharp fin antenna. Okay. Now give any other? Any other?
अलग है ये
Yeah.
Sir, a number of cars have internet connectivity in that segment.
Oh, yeah.
Yeah, so,
Yeah, that's true.
Yeah.
Like I can there's a tagline of one of the MG, Internet Inside. So they are using.
then Bluetooth and wireless connectivity.
Correct. So there are multiple antennas being used. In your side mirrors you'll find. And I'm not talking about high-end cars. They are all mid-segment cars. So they are now the scenario has come where we want things not to be visible. So we could see only the sharp fin antennas. We aren't able to see many antennas which are being used in now many of the cars are coming up with GPS enabled. So there's a GPS antenna that works in the SATCOM band.
So the ADAS system is.
Yes, ADAS system, very true. Now we have ADAS level 1, 2. So they use antennas. Without this, ADAS is not going to work. So the point what I am trying to make is that you will find antenna which was not even in field. Now it has entered into automotives also. But that's not my topic of discussions today. I'll be talking only about the health monitoring. So that was just an example to tell you that what is the use of antennas and where the reach of antenna has been. Another example is like your mobile phones. Okay, all of us use mobile phones. How many antennas do we have in mobile phones? And they are all planar antennas. Another simple name is microstrip patch antenna. MSA we call it, MPA we call it, different names for it. So what do you think? How many antennas do we have in a mobile phone?
Around 30.
There are multiple. But there are few companies who are actually integrating one antenna which could work at different frequency bands. We call it reconfigurable antennas. So earlier we used to have multiple antennas. Gradually we are progressing towards where we could integrate things. We can have a single antenna which could serve various purposes. So there is a frequency reconfigurable. There could be electronic switching, there could be mechanical switching, where you can have variations. So I may skip the introduction part because I thought there might be some students. So every modeling has got some mathematical background. So the work of antennas started way back in 1950, but actual progress took place in the 70s era. So these are some of the models which forms the basis for the simulation. We have got various simulation tools which are available. So the very first major work that was presented in the field of antennas was in the year 1981. There was a conference, and that conference proceeding is like a base. Whenever somebody has to start research in the field of antennas, they used to refer to those papers. There's one paper by Carver where you can refer to these areas. So these are the various models which are available, which forms the basis of antenna designing, and ultimately that led to the tool. So now these models have got some limitations. The limitations are the calculations were very difficult, and there were various constraints. When we are dealing with antennas, you cannot work on a simple geometry. You need to work on multiple geometries. When you are talking about reconfigurability, when you are talking about array, when you talk about MIMO systems, then you have to deal with so many things. So these mathematical models were not able to solve those problems. So what we did, we took the help of simulation. So these models or multiple models are integrated into a simulation tool, and which does the computation part. So basically an antenna in its conventional form is having a limited capability. So if you look at this, bandwidth is around 1 to 2% only. Gain is from 1 to 1.5. So these are not the features that we look for any application, potential applications that we go for. We want enhanced parameters. So you need to make some alterations. You have to come up with the novel geometries. You have to try out something new. That freedom comes when you do more computation. And then followed by computation, you have to fabricate it, you have to test it. Then only you will say that you have validated the work, that it is now working in the right direction. So then comes the role of simulation tools. That is again a very good area for research. A lot of work still going on and still required in this field. So then comes the role of simulation tools. So these are some of the tools which are available. Tools are not limited to this. There are many more tools which are available, And I have mentioned approximate cost, that's not the exact one, it varies. So these are the tools which are available and they are based on which mathematical model, that is also being mentioned over here. So this is an area where you can work on if you have an interest in this area. The people from mathematics, they can collaborate and they can work on the simulation part, or they can go for designing an EM tool. We call it EM tool, electromagnetic simulation tool. These are some of the books which are one should refer to. One of the author is Professor Doha. He is keynote speaker also in this conference. A very well-known figure in the field of antennas. So these are the books which one should refer to if you have an interest in the field of antennas. Now talking about the design considerations. What considerations actually we look for, or we call it what are the performance parameters for an antenna. Like this place must be having a Wi-Fi router. Okay, so what do you really expect? Say you have been assigned a task to go and buy a Wi-Fi router. What do you really expect from a Wi-Fi router? What do you expect? What is the expectations? It should have a longer range. Okay, what else?
So the signal drop-off should be minimal.
Less. So longer range, it could provide higher speed. So that comes what? So what sort of pattern do you look for? Radiation pattern is something that the way in which the power would be radiated by an antenna. So if you want to connect to Wi-Fi, because every antenna has its, or every application has its own expectations. So what are the expectations from a Wi-Fi router? It has to be omnidirectional, correct?
High gain.
It should have high gain. So you want that radiation should be equally distributed over a particular area, such that, and a good amount of bandwidth. I can give you another example, like many of you would be using fiber connections, isn't it? At your home. And it has got two, now they are coming up with two variants, 4G and 5G. Whether it is Jio, whether it is Airtel, they are coming up with two variants now. One is 4G, another one is 5G. What is that? Are they using different antennas? No, they are not. They are using a single antenna which can operate at 2.4 gigahertz band also. Another band is 5.1 or something. Now, what is the difference between, why they are using two? What is the need of two? When you are looking for a longer range, you have to make a compromise with the speed. Then you can go for 4G. When you are looking for high speed and the router is close to your place, then you can go for 5G. So there is always, in this field we say there is a compromise between gain and bandwidth. So gain and bandwidth product always remain constant. So that is where the radiation pattern plays a role. Now in the mobile phones, okay, we all know that a mobile phone is connected to the various BTS, okay, base transmission station, right? So what sort of pattern do you expect? We have a cellular structure, a hexagonal structure. So what sort of pattern do you expect? Do you want your mobile phone to have always, you should talk like this? No, you can place it like this, you can place it like this. So you can have in any orientation, my connection should not be disturbed, isn't it? There should not be any handoffs. We call it handoffs. That means there should be no echo, no call drop. These all things should not be there. So what sort of antenna do we expect? Because a BTS could be as far as 1 kilometer, could be as close as 100 meters. So what sort of pattern do you expect? Can you expect it to be? Again, it is omnidirectional. You want it to be omnidirectional. Along with that, another thing which I have not mentioned over here is polarization. What is polarization? That means even if I keep on my transmitting is same, because my mobile phone is a transceiver, my BPS is a transceiver. Even if I change the orientation, it should not affect the quality of communication. So that is another factor which I forgot to mention over here. That is polarization. Then comes the band of operation. Okay, you all know about GSM bands, isn't it? There are various bands which are spectrum. You would have heard 2G scan. All of you might be knowing. Okay, so there is spectrum allocation. So these allocations are on the basis of those bands. So in which area that is why we need mobile phone to have multiple bands. Suppose there are 3 GSM bands which are operational in this area, my mobile should be able to operate in all those 3 bands. Then comes the position of antenna. Position of antenna is earlier when the mobile phones were launched, particularly to a common people like in our country. When do you think this mobile phone came in the hands of common people like us? Any idea which year it came?
95.
Started in 95, but reached to the people by 99 2000. What sort of mobile phone? There was an antenna. So it was CDMA. It launched with CDMA. Somehow it didn't click. What was the reason for that? Why do we move to GSM? In countries like Japan, we used to have CDMA. Why didn't we move to GSM? We started with CDMA, then gradually we moved to GSM. What was the reason for that? What do you think? Whatever comes to your mind, you can talk.
Interference.
Interference. See, CDMA was the most interference was there. That's true, but that was not the only factor, or I would say that was not a prime factor.
CDMA only allowed 8 users per podium.
See, bandwidth is something which is a limited resource. CDMA was requiring a huge bandwidth, although it was one of the most secure communications. The reason for that was it was using frequency hopping. What do you mean by frequency hopping? I have to communicate like this. My name is Dr. Sayyid Rawat. I will convert it into bits and 010101, it will go like this. Now for every bit, what will be the frequency of operation? That is being decided by a pseudo random code using an XOR gate. So it is hopping. First 0 might have a frequency of 1 megahertz, second 0 might have a frequency of 20 megahertz. Nobody knows that when the next 0 will come, only the pseudo random code, the person who has generated that, will get to know. It was the most secure communication, but the problem was it requires huge bandwidth. You need devices that can operate over the long bandwidth, and that sort of infrastructure was not available. It was a pilot test when we started in our countries. It worked well, but the cost was very, very high. So we moved to GSM because it was not very secure, but it can work with limited frequency bands. That was advantage. So in country like ours, where the subscriber base is such a huge, you need to use frequency reuse policy, which is available in the case of GSM. So there comes the band of operation, frequency band. Positioning of antenna, I can give you the first mobile phone which came. It was half a kg. That was the weight. 2 factors were important in that. One was the battery. Battery was very heavy. And the other infrastructure, including the antenna. I won't say that antenna was having so much of weight, but it was something which was protruding outside the device. Now that part has been replaced by a very thin sheet. Your FastTags is a passive antenna. The FastTag that we use in our cars is a passive antenna, and it is communicating with another array of antennas which is at the toe. So it has become that thing. Now we are working in the area where we are going to have transparent antennas. They are not visible to you. They can be embedded inside this wall. Like this laptop has got antennas somewhere over here. So how many antennas do you think it has? Wi-Fi, Bluetooth, right? These two are must. There could be something for FM also. You can have an app for FM, but it should communicate. It should receive that. Then for that also you would require, because FM is something which is ranging from 88 to 108 megahertz, right? So this would have 3-4 antennas, and they are actually behind this body, right? Now we are working in an area where we'll embed it into the body. Even if you open that cover, you won't be able to see the antenna. It is inside. You will find antennas which are on the windows, like this glass, as transparent as this glass. You have antennas in the textile. I'll give you an example of garment industry. Earlier, all big pantaloons, they used to have a barcode system, isn't it? Now this barcode system has been completely replaced by what? RFIDs. What is that? A passive idea. So what is the advantage of that RFID? No direct communication required. If you are within the vicinity, they can give you where it is located. And now you will see that those RFID tags are being removed. Every clothing now has a RFID. So there comes the position of the antenna. Then comes the beam width. For some applications, we do require them to be very directional, like a horn antenna. Okay, horn antenna is something which is a directional antenna. It has fixed. Your transmitter is fixed, your receiver is fixed. So both the places are fixed. So it has the fixed communication. So when your transmitter receiver are stationary, then you can have a directional antenna, so that you can completely have a pencil sort of beam. We call it a pencil beam. Then there comes the side lobe levels. One is the main lobe, where you want the direction to be. There are certain side lobes, there are certain back lobes, the unwanted ones. So this should be very, very low as compared to the main beam. Size of the antenna I have already mentioned. It has become so small. You want things to be very small, isn't it? Because the mobile phones are getting smaller, or any device are getting small, so you want things to be very, very small. Now, another example I can give you, like you've got an old desktop which is not having a Wi-Fi connection. What will you do? You want to have Wi-Fi connection in an old desktop. What will you do? There's a dongle. Definitely, it will be having an antenna, right? So the dongle is such a small. It's a USB. So you want things to be very small, isn't it? So that is where the size of antenna. Then comes very important thing, SAR. Okay, when you buy any mobile phone, what do you look for? What do you look for? Camera. Okay, processor. Although we are not supposed to do computation on this, still we look for processor, isn't it? What else? What else? Memory. Okay, wait. What else? SAR we never look. Yes. And that's a very, very, very important factor. Yes. Okay. There is one very famous professor, Professor Girish Kumar. He has been working for so many years in this area. He has been talking about the thermal and non-thermal effects of mobile phones. He has done a tremendous work. You can refer to, you Google it, Professor Girish Kumar, you will find a lot of PPTs of it. And that's really a good work. It is worth referring to those things. Okay, I got a chance to meet him a couple of times. A very down-to-earth person. He's a member of TRI also. He actually forced government to look in this area also. He gave so many examples. So SAR is something which is of paramount importance, which we never look for. which we never bother to ask. What do you think? What is the typical, this you everyone might be knowing because there's a sticker now at the back side of the mobile phone. How much should be SAR? It's 1.6. Okay, it's 1.6. What does it mean? What does it mean? It's just not a magic number. What does it mean? What do you think is 1.6? Okay, I can't tell you the calculation, I'll give you roughly a layman's view. 1.6 SAR if your mobile phone has, that means you can talk for 6 minutes in 24 hours. If you reduce the SAR, you can increase the talk time. Now, even if I take, this is something very, when you're talking exact. Now, if I take a relaxation of 3 to 4 times, then what could be the maximum time? 30 minutes. And every one of us, including me, we always used to cross this limit. Isn't it? So SAR gives you that is one calculation which SAR gives. So when you look for a mobile which has a lower SAR, that gives you more leverage to talk for more time, more duration in that 24 hours. That is one factor. Another factor of SAR is that when you talk on a mobile phone, there is a thermal effect, there is a non-thermal effect. What is the thermal effect? There is a 1 degree rise in the scalp areas near your ear when you talk like this. Okay. What is non-thermal effect? Every one of us would have observed that when you even if you're not talking, when you're looking at your mobile phones, the radiation. Okay, if you before sleeping, if we all of us do it. Most of us, I won't say all of us, most of us do it. We watch something, whatever, it could be informative, non-informative, for entertainment, whatever it is. So you may have sleep anemia. You won't be able to sleep when you use devices. So what are the solutions? These are the problems. What are the solutions?
So one is we should try to speak more on speakerphone.
You can use an earphone. Okay. You can talk for less duration, like continuously talking for 30 minutes. You can talk for, you can break it into 5 minutes, 4 minutes, take a break. Keep your mobile phone away from you, especially when you're sleeping. There should be a gap of minimum 1.5 feet, and it should not be at the same level because the mobile phone has a radiation pattern which is omnidirectional. So you should keep it slightly down. So this is what SAR is. Next time when you go for, do look for SAR also. It's an important factor. Okay, something which is related to your health. How much time do I have? How much? I mean, you can tell me because I can talk for full day. You can tell me.
10 to 15 minutes.
So I'll try talking 10 minutes. So this is something what you see, and I have just taken an example of very low antenna. This is an antenna. So antenna designing is not a costly affair. Okay, you can fabricate it. It will cost you less than 100 rupees. But the testing equipments are expensive. Like recently, I got to know that this university has got nano antenna up to 4 gigahertz, which is good for undergraduate level. You can test those things. Students can fabricate, they can get it tested. So you can design an antenna. You design it for simple applications. So design it for Bluetooth, fixed frequency, simple design. You can use simple substrate which is not very expensive, FR4. Okay, use it, fabricate it. There could be 2 methods. I don't know whether you have a milling machine. Even if it is that is not required, you can use it by wet method. So designing is not a difficult. Fabrication is also not a difficult part. The testing is a costly affair. So make use of your, nearby institutions. MNIT has got a facility up to 40 gigahertz. IIT Jaipur has got a good facility, I believe. There are many people. Like I think Dr. Swamik, I go forward to him. So he has been working in that area. They have got a very good facility. Our university has got some facilities. VNA up to 14 gigahertz, and we are coming up to 67 gigahertz also. So make use of them for testing. So this is something which students can design. Okay, so ask them to design it and get it fabricated. If not here, it's not a very difficult one. I think it could be done at your place also, and then get it tested. So students will be able to get some knowledge. They can test that Wi-Fi for Bluetooth, for WiMAX, okay, for DCS communications. So basically, the process starts when you think that what is the frequency range. So say I decided that I wanted to do it for WiMAX. So WiMAX has got 3 bands. Let's decide that we will do it for the lower band, which starts I think from 2.59 to 2.8. So once you have decided the band, you want to design an antenna for this band. Now based on that band size, your overall size will be decided. So generally of this size, I am not doing any I would say simple antenna of any shape of your choice. Maybe it is rectangular, maybe it is elliptical, maybe it is some shape, circular, whatever it is. So once we have decided the frequency, then we can get to know about the size. There are mathematical equations available in Balani's or the different books. Then you can have an initial design based on the formula. Once you have done the initial design, then you can optimize it. You can fine tune your design. Once you have achieved the desired band, what else do you look for? I have shown you some parameters: radiation pattern, bandwidth, polarization, gain. You can improvise that. So once that improvisation has been done, you have reached the final state, which is called as the final parameter. Then you can go for the fabrication. Once the fabrication has been done, you have to use a SMA connector, and then this is an SMA connector, and then you can test 3 parameters in a VNA which you already have, and rest of the parameters like radiation pattern, polarization, and gain could be tested in a room which is called as anechoic chamber. This is a anechoic chamber. So this is a facility which is available at limited places. Like I have mentioned, MNIT, IIT Delhi, IIT Jaipur, many other places have got this anechoic chamber. That's a costly affair. So this students can do. It can be done. Various places it is being done. You have an IEEE APS chapter. Make advantage of that, and you can do the design and do it for your Wi-Fi. Let's have your own antenna in your Wi-Fi router. You can design a router also. It's not that difficult. So now coming to the healthcare. So I'll wind up in the limited time. So that's the healthcare e-future. So we have got a very stressful lifestyle, isn't it? Whether you're a student or a faculty or a teaching, non-teaching, whatever, then we have got extremely, in COVID times you have seen that our healthcare facilities are limited, number of patients are very, very large. If you look for the doctors, how many doctors do we have as per the population? There's a huge gap. So what we can look for? Because something that you will understand, or many of you would have understood, that the wealth is not health, but the health is a wealth. So what could be the possible solutions? It's the prevention. You get to know about your health vitals much before anything which deteriorates, isn't it? So those could be the things. So these are some of the bands in which people have started working. So we have slowly shifted from megahertz to sub-terahertz, and it has got all those applications: 5G, 6G, IoT, SATCOM, all those things are there. And they are also being used for healthcare. So this is one popular one which is called as the millimeter wave therapy. So this is used for detection Okay, and also for treatment. So something which has, and it is, the best part is it is affordable. Okay, it's not very costly. So this is gradually coming. I'll skip this part because this antenna designs will talk only about some of the healthcare devices. All of you know about smartwatches, isn't it? Any smartwatch which is less than 1,000 rupees now has got what? You can get to know about SpO2. You get to know about what?
Heart rate.
Heart rate. What else?
Number of steps.
Number of steps. What else? We have gone a little further now. Okay, you can have a non-invasive way of blood sugar management. Recently, a BITS Pilani student has done it using sweat. That's a non-invasive way, and he is getting decent results. So now we are moving towards invasive to non-invasive methods. Okay, because blood sugar measurement is a painful, isn't it? Every time you have to pinch and take out the blood 3 to 4 times. So that's one thing. Then with Apple Watch, I think 5 to 6 years back only they came up with the ECG part also. It's not that accurate, but gives you an indication. ECG is possible with a smartwatch. So these are the things. Then now we have got a device. You'll see so many advertisements also. There's a patch on your arm which can tell you about your all these parameters, and by the evening it will give you an average. So because if I give you an example of blood sugar level, every person who is diabetic has a different response. It is saying that only when you take something which has sugar creates or shoots the level. That's not the case. That's not the only case. Every individual, every human has a different way of response. Then why same treatment for everyone? So this actually, these kind of sensors, they gives you information. So you get to know that suppose you had a rice. Somebody body may not have, I'm just giving you an example of blood sugar, there could be many other, your heart rate also. Somebody had a rice and the response for a rice could be different for every individual. So once you have a data by the evening, you get to know that these are the factors where I should work on. I should change my food habits. Okay, I should, when I used to wake up 6 a.m. every day. One fine day I got up at 8 a.m. Then what is the response of these vitals? So these are actually the devices that is extraction of the information and finally combining it and delivering you some indications which could be useful. This is one BioShirts that gives you HRV, your respiratory sinus arrhythmia, all those information it could give you. So these are the devices which have been integrated with your clothing. This is the one which I already gave you an example, a wearable non-invasive sensor-based system. This is a patch which I was talking about. So you can have a patch, it is inserted, and then you can do your daily routine and it will give you the responses. This is a non-invasive way for glucose monitoring. You are placing the device on your fingertip and it is operating at the gigahertz and giving a decent results. So that's a sub-terahertz non-invasive glucose monitoring system. That's another way. This is something which is related to your optical brain mapping. So there is a band which is available that gives you the vital information about your brain mapping. This is for your gait correction. The toe, how do you stand, how do you walk, So this is something which is very popular nowadays. So you have gait correction, you can have in your shoes. This is the 5G based COVID monitoring system. It came in the COVID times. You will see so many papers, particularly in the 5G based, terahertz based for the remote health monitoring. Then for drug delivery, our university, there is already a research lab who are working in this area. They have come up with the microneedles, which could be used for a drug delivery to a dedicated portion of your body. So they have already done it. Then this is something very interesting. This is called an endoscopy. You know what is endoscopy? Many of you might be knowing. It's a very painful process. So there is one endoscopy capsule which you can swallow, and which to do this, you can have the drug at the particular portion of your body, somewhere close to intestine or wherever it is. So this has got an antenna. There is a battery. There is a micro needle, which is meant for delivery of the drug. So this is something which you will see in coming years very common. It's like a tablet. You swallow it. It will go inside, do the job, and then will come out. These are some of the variables which are very common. This technology, where it is actually generating the power. It is like self power. So it is generating the power through your movement, feet movement, and many of the students have come up with this. And there's one startup also working in this area. They're coming up with the shoes which can generate power, and it can power not only what, it can power your band also, whatever different devices that you have. So these are some of the applications. Then the last part is the AR/VR therapy. Now you have got patches. Again, this is many people are working on this, where you can feel. Suppose you are working in the augmented reality. The government has also sponsored AR/VR labs. So many institutions are already there having AR/VR labs, where you can place a patch on your hand, and suppose you are in the AR, you are using an AR, you can feel, suppose you are in desert, you want to feel the heat. So through those patches, you can have the real-time feeling, as if you are already in that place. So these are some of the applications where typically we are using the antennas, and in all those applications which I have just shown you, they are already in place. People have worked, and they have come up with the novel devices. So my only advice to you is that start working in this area. If you have an interest, make your own antennas, use them, and you'll feel that's something you're doing. So that's all from my side. Thank you. If you have any questions, okay, no questions? Thank you.
Thank you. Thank you very much, Dr. Rawat, for that insightful speech. Now, as a small gesture of our gratitude, may I request Professor Prishita Chatterjee, sir, to kindly present the memento of appreciation to sir. Thank you, sir. I now request Professor Vishnuja Chatterjee sir to kindly share his thoughts and deliver vote of thanks for today's session. Please.
Thank you so much to all the thank you so much to all the attendees over here for your patient listening definitely, and it was a wonderful topic going on, and you can understand that those who are belonging to the topic, you are into antennas and you are definitely doing the research on it. Those who are not into this topic, not into antennas, you can still understand that the signal needs to be properly taken in. Only then processing of signal or utilizing it properly can happen. So definitely antenna plays the biggest role, and the research on antenna should continue. Research on antenna should continue big like it is happening. And I'm sure that government has taken many steps on that. Many initiatives are there. I request the teachers who are relating to this, who are into research of antennas, to kindly progress on this, and maybe you can prepare a better lab. So whatever is needed for a better lab, the department may kindly talk to us, and maybe you can have better lab in place at our university too. Definitely you have, but you can improve and make a much better lab. So you definitely try to do that. I wholeheartedly thank Dr. Sanjeev Rawat sir for coming over here and delivering the keynote speech. Sir, thank you so much for your presence over here, and you have really delivered something through which we have gained, and our knowledge level definitely increased to a certain extent. Thank you so much for your wonderful speech, and believe me, you were very relatable. Like even if somebody is not from the topic, could relate to you very well. Thank you for keeping it simple and understandable for somebody who is not into the topic of this research. Thank you so much for that. Thank you. Thanks to Dr. Neeturaj Singh sir and Arpit sir for coming over here again and being present in this keynote speech, and all the teachers who are present over here. My wholehearted thanks to the organizers for organizing this conference and making it definitely a success. This conference is very close to our heart, as I said yesterday also, that this is the first conference that was ever organized in Jaipur. This is the 13th version of it. So now we are having a conference from every department, as the students over here can relate, the teachers over here can relate, that we are having one conference every department at least. And some departments we are having 2 or 3. So yes, Professor can relate, he is having 2 conferences in his department, and CSE is having 3 conferences. Fine, very good. I'm happy to understand that. But this conference still remains very close to our heart because this was the first conference that was ever organized in this university. So this is the special, this is a special one for all of us. Thank you for being a part. Thank you for organizing. Thanks to all the keynote speakers. Thanks to all the paper presenters. Thanks to all the listeners, the audience, the students, the teachers, all my colleagues. Thank you so much.
Thank you so much, sir. Now we move ahead with the online presentation. We request all the audience to join the online session. Thank you.
So we are having the next online presentation in the Google Meet. We will currently join the session. You may join via the links.
ये सेशन के लिए अभी यहाँ पे फिजिकल की नोट और है क्या आज ये वहाँ तो सिर्फ ऑफिस में ले चलना बाद में आके ले चलना ठीक है इनको बॉयज को बोलो ना सेशन और वो पे एक साथ के ऑफिस में
कुछ काम करिए यहाँ पे कौन सा ट्रैक
क्या ये अच्छा मुझे भी याद है
Yes. You are audible.
Start.
Good morning. Hello.
Yes, sir, you are audible.
Yes. So can I start?
Yes, sir, you can start.
Okay.
इसका कैमरा इस साइड करके दिखा दो इसको तो लोग उनको लगेगा कि वो यहाँ पे देख रहे हैं एटलीस्ट ये लैपटॉप
My screen is visible. Hello.
यस सर इट इज विजिबल
Okay. Thank you. Okay. So, hello. My name is Shuman Shami. I am a faculty member of IEMECON Global. So first of all, thank you for inviting me for giving this keynote talk. So and also I would like to congratulate all the UEM fraternity and organizing committee of this conference for successfully organizing this conference. So in this keynote talk, mainly I am going to discuss this topic, that is the time level and optimization techniques with real world case studies in speech, biolinguistics, and vision. Primarily, this talk is for master students and research scholars who actually in their initial stage of their research. So, although this is very mathematically intensive topic, but due to the time constant and the scope of this conference, that I couldn't cover all these things. So it is kind of an overview. So let's start with the very basics. So what is time linear? So time linear nowadays is a very popular term in machine learning, machine learning community. And although it was coined by the scientist Peter Martin in 2018 or 19 like this. And so what is tagging? So tagging basically is a kind of a technology where we try to blend the two things. One is embedded systems and another one is machine learning. And so why we do it? Because we want some efficient inferencing facility from after the model is trained. Okay, so what I mean by that, so dynamic ML basically enables that how the real world applications in the real world application or in real world consumer electronics products, how we can use the machine learning inference. Because most of the time we know that to train the model using the cloud server or our own server using which is computationally very fast. But once the model is trained, we need to do the inference. We need to evaluate every new or unseen data on the model, right? So what do we do that we require and in real world we know that we want some portability. We want something which is very tiny in shape. Okay, we should not be always a very computationally efficient platform, right? So we want very fast, latency free, and slow latency, fast, and high performing machine learning model. Okay, so that we can deploy it on some small microcontrollers. Okay, so we can say that this timing is kind of a something of an AGM. Okay, so AGM, so when we run something on mobile phone, that is kind of a edge devices. But our time-able models will be much more efficient, much more lightweight, so that we can deploy it on much more smaller tiny devices or microcontrollers. So that is, we have seen that there is a paradigm shift in machine learning technology that from the cloud ML, we first went to the HML and now we are time ML era. So we see that nowadays we have plenty of in-device product which supports time ML. So all of us have used some kind of a audio assistants or speech assistant or voice assistants like a Alexa or Google assistants. We all might be using smartwatch, okay, or some very intelligent cameras, right? So which are having AI features. So all these devices are kind of exploiting the technology that is called the time element technology. So time what are the features it does have? It is the fastest growing field of ML. It has so basically what it is enabling is that we can do near sensor processing and it could be a very fast processing. So since we are going to use it in a real life always, so it needs to be the tiny ML devices must be low power, should be battery operated, or they should be consume very less amount of power. They should be always on kind of a model, right? So these are the features that we require from any tiny ML applications. So there are plenty of applications in audio signal processing, in computer visions, in any kind of in predictive maintenance, okay, or any kind of surveillance in healthcare. So whenever you have a real time prediction is required, real time kind of a computation is required using machine learning, we can use the tiny ML inferencing. The inferencing based on tiny ML concepts. So as you can see, there are plenty of advantages of timing, like on-device sensor analytics, low power consumption, and so that is that. Also, it will be on-device computation. So obviously, we don't require any kind of a network support. So offline capability is there, and which basically also indicates that we can have a privacy preserving features. So which is basically improving our security and privacy, right? And obviously it has to be low cost, right? So TinyML has all these benefits that we need to exploit whenever we want to implement any kind of application using this TinyML technology. But the problem is that there are plenty of challenges, right? Because at least what I have discussed, it is the benefit of them. If we do it correctly or do it properly or efficiently, then only we can achieve this benefit. But plenty of challenges is that the model deployment, right? The model deployment is extremely hard because this whenever I'm saying there is a tiny tiny device means I mean to say some kind of a hardware platform, right? And these hardware platforms that we are going to use for tiny devices are they are very resource constrained, right? Like we need to add, and they don't even match with our mobile phones. Nowadays, our mobile phones have plenty of RAM, flash memory, and it can consume lots of power, right? But our tiny memory won't be supporting this. So what we require, so tiny memory constraints is kind of a thing that it is actually consume 1 milliwatt order of power. Its flash memory will be 1 MB. So in 1 MB memory, we need to incorporate my model and code, everything. And RAM would be like 256 MB to 512 KB, not an MB, it's KB. So where you need to, that is your active memory will be consumed, right? So what are the tiny device? So nowadays we can use quite a few tiny ML development boards. Some of them named given here Arduino, Nano, TVX, Spark, or ST microelectronics also have some board. And these are the tiny ML boards, and they are very small in size. Okay, although they have AI capability, but their size is very tiny, and you can see their resources are very also hardware resources are very computational less. Okay. So the problem is that the models which are made for mobile devices, machine learning models, those are also not quite suitable for tiny device. So you can see that there are many computation models are there, right? There is mobile name. Okay. They are very much well efficient on our cloud AI or mobile AI, but those are not quite suitable for tiny AI because tiny AI having 1 MB of memory or 256 KB memory or RAM, right? So flash memory is a bottleneck, and also the RAM, the active memory is also a bottleneck. So you can see that you can compare that the inference memory, the training memory, although we are not talking about the training here, only inference. So inference memory or the active memory, those will not be supported. Of these models will not be supported by the tiny memory devices. So what we require is that the problem is that in machine learning that lightweight model architecture is required. So that is the main or many models which having less number of parameters. So that defines the model size, right? So we require lightweight model. So in order to get light, but the problem is that in machine learning, the large model produces better results, but it runs slower. And smaller model produces worse results, but they runs faster. So that is the problem, right? So what to do with this scenario? So for that, there are different techniques. So it is basically called hardware software co-design is mainly required. As you can see that the hardware also has things to play, right? And the software also, the machine learning part also has something to do with this. So time level is a kind of a umbrella of topics where you have learning theory, algorithms, optimization algorithms. In the hardware side, we have different kinds of libraries, firmwares, and the hardware implementations or accelerations is required to get a better time implementation. But now I am going to discuss only the part of ML part, machine learning model development part, where we can use how we can use the different type of optimization techniques for tiny ML for developing the tiny ML models. So there are many methods for creating a small memory footprint in my model development, network architecture, learning technique, model foundations. So out of this, I am going to discuss a few topics that my students are working on it. So first of all is a compact. So the one thing that we need to a compact network design. So usually what we do, we use different kind of techniques for optimizing the convolution of populations. Okay, so normal CNN that takes too much number of parameters, and instead of that we use bitwise convolutional operations. And there are different techniques of tensor decompositions of this, making it much more efficient. And there are plenty of lightweight neural architectures also, mobile net, efficient net, tiny net. But again, this squeeze net, all these are quite good enough for mobile phones, for our mobile net, right? But these are not, or as a HD web you can say, but these are very, very good. But these are not again suitable for tiny memory devices. There are some kind of a post-processing technique is also there after the model is training. It's called pruning. So it's called wet pruning, or so you can see that some kind of a technique, some of the methods is used to remove the redundant weights from a neural network. Okay. So this is also some kind of effective, but they are not as much effective for tiny memory. So if I only use these techniques like a post-processing model compressions tuning and quantitative, those are not very much effective. We need to first of all develop the model profile. So for that, one of the most important techniques called network architecture search. So what is network architecture search? In network architecture search, we define a hyperparameter set of the neural network, or we say the CNN. Suppose it has different kinds of hyperparameters like number of convolutional layer, kernel size, number of filters, stride, and different kind of activation functions. And it is very difficult. So as you know, in neural networks, the problem with the hyperparameters. So what is the problem is that how to find out the optimal hyperparameter set for which I will get the optimal performance. And I'm talking about the optimality in the both the sense, because for time limits we are a hardware constraint. So power consumption, the hardware, the total number of parameters, the performance, all are kind of our object. So we want to maximize the performance, suppose accuracy, and I want to minimize the also the number of parameters of the model set. So this is the so what we can do, we can apply searching algorithm to in the hyperparameter searching space, and we can find out the optimal model model. So here we have to use a multi-object hyperparameter optimization, and because this is a time level, so we have lots of hardware constraints are involved. So and from that we finally will get a Pareto optimal set. So from that we get, since we have a multi-object optimization, so ultimately we get a Pareto optimal models, which will tell me that these are the best models which can be used for time level implementation. And again, so since it is a multi-object combinatorial multi-object optimization problem, so obviously we need to we have to do the trade-off between search cost and solution quality. So we have used different kind of techniques. We can use a different kind of meta-linguistic techniques like genetic algorithm and Bayesian optimization, probabilistic models, and so it is a kind of a complicated optimization problem becomes a bi-level optimization problem, because as you know that every time you need to do kind of a optimization in two levels. First, you have to find out a sample parameter, and then you have to do the optimization to train the model, right? And then you have to sample another point. So it has to be sample efficient, right? And the efficient sample evaluation is also required, right? And it is a kind of an exploration versus exploitation balance has to be maintained. So here I am going to discuss this one case study of keyword spotting, where you can see that keyword spotting is a technique where we found a set of keywords. I want to detect a particular keyword, suppose, okay, and it is being deployed in a tiny device, so it is a Arduino board in the Arduino board. So for that, suppose I want to create a tiny model. So how to do it, right? So there is a normal keyword spotting pipeline, design pipeline. So starting from the audio signal, the features, then we have a neural network, it is doing the prediction. So again, the thing is that we have a multi-objective framework whose main objective is to create a set of models by maximizing the accuracy and minimizing the model size. And again, the thing is that we have can use different kind of a NSG, different sampling method like NSG2, heuristic methods like simultaneously, a sequential model-based optimization, region optimization, and we can find out the different type of solutions. So here you can see that this is an example how we can, for different type of model architecture, CNN, CRNN, DSCNN, we can find out different kind of direct optimal models. And these direct optimal models, you can see that for different kind of colored dots, you can see this models are being, these are the direct optimal, so there are results from different kind of algorithm, NSG2, MOVE, and similarly. Now, the thing is that so we have to compare them also. So based on their this based on the profiles, based on based on different criteria, we can compare them also, like how the optimization has been taken place. So these are the multi-objective optimization matrix, so hypervolume, GB, IGB, and space. So these are the rank of parent optimal models. So this is how we can define all these discovered models, the base models. So rank 1 to rank 7, rank 8, or here rank 7 actually. So they are provided. So this is one of the techniques. Similarly, we can have a knowledge distribution technique. So in knowledge distribution technique, usually we use a two teacher-student kind of a setup where the student model not only learn from the teacher, it also learn from the data set also. Okay. So it can then we define the loss functions, and then it will modify the different loss function, and then basically the idea is that although my student model will have a very less capability, but it will be able to learn from a well-trained large teacher model and its data set. So that is the main idea. Okay, so we have applied this to different kind of another kind of application like a bird or identification. So from the bird sounds or the we can identify what kind of which species of bird it is. So similarly, we can also have a multi-stage methods. Like first we do the optimization, multi-object optimization, which will find out the set of models, and then we can apply the knowledge distribution to boost the performance of the student models that we have obtained in the first stage. So we can see that suppose this is the model architecture of the teacher, it is first wave trained, and once it is trained, then we can apply the optimization algorithms and we can find out different kinds of student models, and then we can boost them using the knowledge distribution. So we can see there that there are different student models that we got. That is the PKD, that is all those are discovered from the multi-objective optimization, and after applying the knowledge distribution, it is being boosted, their performance has been boosted, right? So this is another approach of doing the or getting the efficient and models. Okay. So there is another approach could be the curriculum learning based knowledge distribution, where sometimes what happens, the teacher model is not very much confident in getting maybe it has good accuracy, but it's not confident. So its prediction is there is a loss of variance in this prediction confidence, right? So in this kind of scenario, what we do? Suppose what we do first, we try to get the teacher confidence estimations, right? Using multi-channel Doppler technique, and then what we do? We try to apply a curriculum based on the by splitting the data set from starting from the very easy, then easy data set, then the medium, as a medium, medium data set means from the difficulty level, I would say, and then we do the hard data set, that is the difficulty level of the data points is very hard with respect to the teacher. And then we train the same way the knowledge distribution that is being that we have done earlier, right? This way. And this is the technique. And then we dynamically also we change the wisdom ratio, that is basically the ratio between the how much knowledge the student should take from the data set and how much the student should take from the teacher, right? So this way we can change this alpha dynamically. Okay, so that always the student should not rely on the data set and in a very deterministic way. Rather, it should be dependent on the model side and the data point confidence of the student teacher that also influences this process. So that is also very much effective in we have seen, and this is the basically the baseline results. So we have seen that this is applied on some computer vision tasks like hydrophobicity classification. We see that this curriculum-based knowledge distribution yields a significant improvement when we use for annual when we do there is annual constraints is there and this kind is very much useful. So these are the things of tiny different kind of tiny algorithms that we can use. So it is just one, some of the techniques I have shown you, there are plenty of techniques. So if you are starting your research in this domain, in machine learning, obviously you can explore the area. I think it will be a good field for exploration for your research journey. Okay, thank you. So that is my very here I'd like to conclude, and if you have any question, please feel free to ask. Hello. Hello. Okay, if you don't have any question, then I want to conclude and I will let you know. Okay, thank you very much.